in section 8.5, we're going to further the factoring method and the zero product property. So before we start, we're actually going to look at a review problem. So we're going to take x plus 4 times x plus 3. So remember, what you're going to do is distribute. We're going to take x times x, which gives you x squared, x times 3, which gives you 3x, 4 times x, which gives you 4x, and 4 times 3, which gives you 12. And then I would just combine like terms, the 3x and the 4x, and I would get x squared plus 7x plus 12. So the first question says, how was the first term found? So the first term in our answer was x squared. We got that by taking the x times the x, which ended up being the first term in the first binomial times the first term in the second binomial. How was the middle term found? So the middle term was 7x. It was found by taking the 3x and the 4x and adding them together, which, think about it, 3 plus 4 is 7, and we had a 3 and a 4 in our binomials. So the middle term was found by adding. The last term, which in this case was 12, it was found by taking 4 times the 3. So again, the middle term was found by adding. The last term was found by multiplying. And so what we're going to do in this section is go from this back to that, down to the two binomials. So just keep in mind, the first term is found by taking the first term times the first term, so x times the x. The middle term was found by taking these two numbers and adding them together, and the last term is found by taking those same two numbers and multiplying them. So what we're going to end up doing is, when you're given something like this, you're going to look for two numbers that multiply to give you the last term, that add up to give you the middle term. It is that idea that we're going to use time and time again throughout this section. So again, to reiterate, if I'm factoring, so remember I'm breaking down x squared plus bx plus c, what I want to find is two numbers, p and q, that add up to give me the middle number, which is b, and that multiply p times q to get the c value. So again, when I'm breaking down something in this form, I'm going to look for two numbers that multiply to give me the last term and add up to give me the middle term. And one more time, when factoring a trinomial in this form, what you want to do is find two numbers that multiply to give you the last number and add up to give you the middle term. Make sure you write this down in your notes. So let's move on to example number 2. It says factor the trinomial x squared plus 10x plus 18. So remember, I want to break this down into two parentheses, into two binomials. I know that I'm going to take the first number here times the first number here to get the first term in my trinomial. So the way I would get x squared is if there was an x here and an x here. Because again, if I think about multiplying this back out, I would have to take x times x to get that x squared. So to fill in the other spots in our binomials, we need to figure out what two numbers multiply to give me 16 that add up to give me 10. So I'm going to be looking for factors of 16, and then what factors of 16 add up, so the sum, to give you 10. So I just set up a little table here to get our minds going in the right direction. So 16 times 1 would give me 16, but 16 plus 1 is 17. So I know that this one won't work. 8 times 2 gives me 16, and 8 plus 2 gives me 10. So I know that this one's going to work. But just for clarity's sake, let's look at 4. 4 times 4 is 16, but 4 plus 4 is 8. So again, I know that I'm going to use the 8 and the 2 in order to complete my factoring of this trinomial. So I would need x plus 8 times x plus 2. So again, I've picked the 8 and the 2 since 8 times 2 is 16 and 8 plus 2 is 10. So then it's just a matter of filling it in to our two binomials that we're factoring the trinomial with. So one way that you can make sure that you are getting this correct is just by multiplying it back out. So x times x is x squared, x times 2 is 2x, 8 times x is 8x, so 2x and 8x is 10x, just like we want, and 8 times 2 is 16. So I now know that I have successfully factored this trinomial down to x plus 8 times x plus 2. So now let's look at example number 3, which is just more examples. It says factor each trinomial. So part A says x squared plus 3x plus 2. So we know that the highest power is 2, and we know a trinomial breaks down to 2 binomials. So what I'm going to start off with is figure out what should go first in my parentheses. If my first term is x squared, I know I need an x here and an x here. Now I need to look for the two numbers that multiply to give me 2 that add up to give me 3. This one's going to be easy since 2 only has 2 factors. 1 times 2 is 2, and 1 plus 2 is 3. So I know I'm going to use 1 and 2. So this is just as simple as putting the plus 1 here and the plus 2 there. I could have also put it as x plus 2 and x plus 1. It would be the same thing since we know that multiplication is commutative, and 2 plus 3 is the same thing as 3 plus 2. So x plus 1 times x plus 2 would be the same thing as x plus 2 times x plus 1. Remember, you can always check your answer by multiplying this back out. X times x is x squared, x times 2 is 2x, 1 times x is 1x, so that 2x and that 1x together gives me 3x in the middle, and 1 times 2 is 2. Problem B, a squared plus 7a plus 10. So again, I know that this trinomial is going to break down to 2 binomials. I know that I'm going to have a's in the front because when I multiply this back out, I need a times a to get that a squared. And now I'm going to look for two numbers that multiply to give me 10 that add up to give me 7. So I'm thinking of 2 times 5 because 2 times 5 is 10 and 2 plus 5 is 7, exactly like I wanted. I would not want to use 1 times 10 because even though 1 times 10 is 10, 1 plus 10 is 11, which again, I need the 7 in the middle. So these are not going to work. So I'm going to use the 2 and the 5. So I can put the plus 2 here and the plus 5 there. Again, just like before, I could have put the plus 5 here and the plus 2 there. It doesn't matter since we know that multiplication is commutative. Problem C, we have t squared plus 9t plus 14. So again, we break it down to 2 parentheses. Since the t squared is my first term, I'm going to put a t here and a t here. And I'm going to look for two numbers that multiply to give me 14 that add up to give me 9. So I'm thinking about the factors of 14, and I'm drawn to 2 times 7. 2 times 7 is 14, and 2 plus 7 is 9, just like we want. I could have also looked at 1 and 14. 1 times 14 is 14, but 1 plus 14 is 15, and I want that 9 in the middle. So again, I'm going to use the 2 and the 7. So I'm going to put plus 2 here and plus 7 there. As before, I could have put the 7 here and the 2 here. It wouldn't matter. And again, always think about multiplying it back out to make sure you get what you started with. And this would. I'd have t times t is t squared. T times 7 is 7t, and this would give me 2t, so 7t and 2t gives me 9t in the middle, and 9 and 2 times 7 is 14. As we've talked about before, this process is just going to get easier the more you work at it. So you're going to see a lot more examples later on in these notes, and we're going to be doing a lot of it in class. So if you're struggling with this right now, rest assured that we will get lots and lots of practice, and this is literally one of those things that just practice makes perfect. So here's example number 4. It says factor the trinomial x squared minus 5x plus 6. So notice in the previous examples, it was always a plus sign here and a plus sign here. But now we have a minus sign and a plus sign. So we're still going to break it down to 2 parentheses like we have before. But we have to approach it a little bit differently since our signs are different. Again, we have x squared as our first term, so I know I'm going to have x here. So now I need to think about two numbers that multiply to give me positive 6 that are going to add up to give me negative 5. So think about if my two numbers were negative. A negative times a negative is a positive, and a negative plus a negative is a negative. So when I'm looking at the two numbers that multiply to give me 6 that add up to give me negative 5, I need those numbers to be negative. So if I do negative 2 times negative 3, I'm going to get positive 6. If I do negative 2 plus negative 3, I would get negative 5. So in my parentheses, I would have x minus 2 and x minus 3. Again, I could have put the minus 3 here and the minus 2 there, since again, multiplication is commutative. But, so again, this is your answer. And just to reiterate, I needed two negative numbers, since a negative times a negative is a positive, and a negative plus a negative is a negative. So here's another example, number 5, factor the trinomial. This time we have x squared plus 3x minus 10. In the last example, it was a minus sign here and a plus sign here, and now we have it switched. The middle number is positive and the last number is negative. So think about this. The only kinds of numbers that I can multiply to get a negative number is if one of them is positive and one of them is negative. So I know in my parentheses, I would have x plus, and I'm going to have an x minus, because when I take this number times this number, I have to get a negative 10. So when I'm looking at the factors here, I need to figure out what two numbers multiply to give me negative 10 that add up to give me positive 3. So think about the factors of 10. I'm thinking of 2 and 5. So 2 times 5 is 10, but remember I need it to be negative. So if I have 2 plus 5, which one of those numbers would have to be negative in order for me to get a positive 3? If the 2 was negative, negative 2 plus 5 is positive 3. So negative 2 times 5 is negative 10. So the 2 needs to be negative, and the 5 has to be positive. So in this case, I could have put the minus 2 here and the plus 5 here, but we have to make sure that the 5 is positive and the 2 is negative. So again, think about two numbers that multiply to give you a negative 10 that add up to give you positive 5. I believe this will be the case that you're going to have the most trouble with, just because one number has to be positive and one number has to be negative. But as I said before, this will get easier the more you practice it. So our last example, number 6, has us solving the equations. So this is where we're going to use the zero product property. So just to reiterate from the last section, when you use the zero product property, your equation must be equal to 0, and your equation also must be turned into a product, which means a multiplication problem. So if we're looking at problem A, it says solve the equation. X squared plus 7x equals 18. So the first thing I notice is that this equation is not set equal to 0. So I would have to subtract 18 from both sides. Since 18 is not a like term with the x squared or the 7x, this would just turn into x squared plus 7x minus 18 equals 0, since that's going to get rid of it over on the right-hand side. So now I have it set up as a 0. Now I need to set this up as a product. So I have a trinomial. I know a trinomial can be factored down into two binomials. So just like we were doing before, to get this x squared, I would need to have x's here. And then I'm going to look for two numbers that multiply to give me negative 18 that add up to give me positive 7 in the middle. So I'm thinking about 9 and 2. So 9 times 2 is 18. But remember, I need to get a negative 18. So one of these numbers needs to be negative. If I take 9 plus 2, how would I make that a positive 7? Which number would have to be negative? So the 2 would have to be negative in order for us to get a positive 7 in the middle. So the 2 is negative. So when I set it up in my parentheses, I would have to have a plus 9 and a minus 2. So again, when I do that middle term, 9 times x is 9x, and x times negative 2 is negative 2x, which would combine to give me 7x in the middle. So remember, if your last number is negative and your middle number is positive, or if it was negative, you would have to have a positive and a negative number within your parentheses. So back to the main point of this problem. Remember, we were supposed to solve. So now that we have it as a zero product, I need to figure out what will make this parenthesis equal to 0 and what will make this parenthesis equal to 0. So it's just as simple as taking each parenthesis and setting them equal to 0. So negative 9 plus 9 would give me 0. So my first answer is negative 9. And in this case, I would add the 2. So 2 minus 2 would give me 0. So my two answers are negative 9 and negative 2. Now let's move on to part B. Solve the equation. Negative x squared plus 12x equals negative 13. So remember, we're going to use the zero product property in order to solve this. So the first thing we need to do is set the equation equal to 0. So since it's a negative 13 on the right-hand side, I'm going to add 13 to both sides. Just like before, 13 is not a like term with the negative x squared or the 12x, so it's just going to be negative x squared plus 12x plus 13 equals 0. But before we can turn it into a product now, we recognize that this number is negative. You never want to start off your problem with your squared term being a negative. So we need to take this negative sign out. So I'm going to factor out a negative sign, which if I take the negative sign away from here, that's going to turn each of these into its opposites. So I would get negative times x squared minus 12x minus 13 equals 0. So think about redistributing this negative sign. So negative times x squared would give me that negative x squared. Negative times a negative is a positive, so I'd get that positive 12x back. And then a negative times a negative gives me a positive, so I'd get that positive 13 back. So again, your first number cannot be negative. If it is negative, take a negative out. So make sure that you have this written down. If the first term is negative, factor out a negative, which just changes everything to its opposite. So back to our problem. We took that negative sign out. Now we have x squared minus 12x minus 13. We have a trinomial that we need to break down into the product of two binomials. So that negative sign is still just going to hang out here by itself. I'm going to break it down into two parentheses. I know that I need to have x squared when I multiply this back out, so just like always, I'm going to have x's in my first two blanks. And then I need to figure out what two numbers multiply to give me negative 13 that add up to give me negative 12. So remember, one of these is going to have to be positive and one of them needs to be negative, because when I take a positive times a negative, I got to get that negative 13. And then I need to figure out which number is going to be the negative so that when I add them together, I get that negative 12. So 13 is prime, so I'm only working with 1 and 13, because 1 times 13 is 13. But I need to figure out 1 plus 13, how will I get that negative 12? Which number would have to be negative? The bigger number would have to be negative in this case, so I get that negative 12. So the 13 is going to be negative, so I could have minus 13 here and plus 1 there, since the 13 had to be negative and the 1 had to be positive. So now let's go back to the problem at hand. It said to solve the equation. So I have it set up as a 0 product. So now I'll take each of the factors and set it equal to 0. There really is no sense in setting this negative sign like this negative 1 equal to 0 since there's no x in it. So I'm going to take the x minus 13, set it equal to 0, and take the x plus 1 and set it equal to 0. So in this first case, I would add 13. So my first answer is x equals 13. And my second answer, I would subtract the 1 over, so my answer would be x equals negative 1. So my two answers are 13 and negative 1. Remember, you can always take your two answers and plug it back in for the x's in your original equation to make sure it works out and gives you a true statement. That's it for this section. Make sure you jot down anything you don't understand that we can cover in class, and we'll see you then.